Hello, welcome to Short Circuits. My name is Pracheth, and in this video, I'm going to show you how to make a CO level sensor or air pollution level meter using RPI Pico and this sensor NQ7. So this is a sensor NQ7 which is sensitive to the CO gas. It has got 4 pins which are A0, which is analog output, D0, ground, and VCC. So we are going to use ground, VCC, and A0. This sensor has got one filament coil which heats up the gas which is present in between the two conducting pads. And when that gas heats up, these two conducting pads start to conduct, and that resistivity determines the analog output, which is directly proportional to the concentration of the gas, the CO gas. So in this way, this sensor detects the CO gas. We have to generate some signals in order for this sensor to work. So let's see first how this sensor has to be interfaced. By the way, CO is a very harmful gas and its concentration has to be measured and displayed, because if you breathe it for too long it can cause dizziness. So let's move on to the project and make this circuit. So let's take a look at the data sheet of MQ7 before making the circuit. So the circuit voltage is 5 volts. Heating voltage high is 5 volts, heating voltage low is 1.4 volts. And this is the construction diagram of MQ7. You can see there is one coil, and across this coil, this H, we have to give voltage. We have to apply 5 volts and 1.4 volts. And we get our output analog data across A and B, which will give it to the microcontroller. And this is the graph which shows concentration versus the resistance. And it has got a very linear relationship between the resistivity and the concentration of gas. And this is the signal that we have to generate: high 5 volts for 60 seconds and low 1.4 volts for 90 seconds. Now let's generate this signal using microcontroller and then connect the sensor to it. So I've programmed the RPI Pico to generate the signal necessary for this NQ7, which was 1.4 volts for 90 seconds, 1.5 volts for 90 seconds, and right now this GPIO 15 is generating a PWM signal which is giving us 1.5 volts at the output. I will hold this probe here and I will show you that it's 1.5. After 90 seconds, this LED will turn off and the voltage will be 5 volts. But the maximum voltage of RPI Pico is 3.3. So it will not be 5 volts, it will be 3.3. So to convert it to 5 volts, I'm switching using this IC to switch. So this is the input to switch 5 volts. So it's just as a transistor. This IC is an array of 7 BJT transistors, power BJT transistors, which will switch the input signal, switch 5 volts as the input signal is applied to the base. So this is input 1 and this is output 1. This is input 2 and this is output 2. But I am not using the rest of 6 transistors. I am just using input 1 and output 1. So output 1 is connected to the heater coil of NQ7, also to one LED. So the LED is turned off. Our 90 seconds are complete. Now let's take a look. So it must be 3.3 and it's somewhat near to 3.3, 3.23. So our signal is being generated. Here you can see 5 volts. So it's switching ground. So I'm probing it like this: ground at the output and positive here. So it must be 5 volts. But as you can see, it's not 5 volts, it's 3.3. Why is that? Because because of the loading effect of this heater coil. So I will unload this heater coil, and you can see as I unload this, you can see that the voltage here rises to 4.3. It must be 5 volts, but still it's 4.3. Let's assume that there is some voltage drop across this transistor. In this way, our signal has been generated, but this 3.3 volt which is generated after we load this NQ7 does not affect the circuit function. That is what I wanted to say. But even if we are not giving full 5 volts to the heater coil, it still works. So this is the complete code for air pollution level meter, and right now the code is running on our pico. This code is written in Thorny IDE, and this programming language is MicroPython. So I'll go through this code from machine import pin ADC, PWM import time to give delay, and PWM pin 15 is given name VSG. I have connected one RGB LED at the output to indicate different levels of pollution. LED H is the LED which indicates that we are in 1.4 volts phase or 5 volts phase. So in the loop, first line I have written VSG.duty is 65,534. That means we are generating high voltage on pin 15, that is 3.3 volts. And we will keep that 3.3 volts for 60 seconds. That's why I've written the next line in for loop. It will repeat 60 times, giving a delay of 1 second. So after 1 second, the count will increment. And once the 60 cycles are complete, and during this 60 cycles, it will also print the ADC value, and it will also compare it. If it's less than 31,000, that means the air is pure and white LED will turn on. And if the value rises above 31,000, then red and green will turn off and blue LED will turn on. So the circuit is right now on and the sensor is connected. I also have connected one RGB LED at the output to show the air pollution status. So right now it's blue, that means the air quality is good. It will turn to green, then purple, yellow, and finally red if the air quality gets worst. So let's introduce some fumes over this sensor. So these are the fumes of incandescent stick. As you can see that the air quality is getting worse. The LED has to turn to yellow. If it turns to red after this point, it means it's dangerous. So when this LED is not on, then only the status will be seen on this output LED. So let's wait for this LED to turn off. This LED has turned off and you can see that the LED is red. That means the air quality is worst. Now it has turned to yellow because the fumes are escaping this jar. Then green. If I lift this jar, it will turn to blue immediately. No, it has not turned to blue, so I will turn on the fan. After turning on the fan, the fumes are swept by the air and you can see that now it has turned to blue. Now the air quality is good. If it turns into white, that means it's the purest. So this circuit works and it shows us the air pollution status, and it's good to be installed in public places where there is pollution